Welcome to Timeless with Vivek Nittoor. Our guest today is Arnab Bhattacharya. Arnab is a scientist and science communicator at the Tata Institute of Fundamental Research, TIFR, in Mumbai. His group works in the area of semiconductor optoelectronics, focusing on epitaxial growth, nitride and oxide semiconductors, 2D layered materials, and nanowire devices. Arnab pioneered Chai and White, a fortnightly science cafe, and is presently the chair of science popularization and public outreach at TIFR. Arnab earned a B.Tech in engineering physics from IIT Bombay in 1992, an MS and PhD in physics from the University of Wisconsin, Madison in 1993 and 1997, respectively. I know Arnab from my days as a student at IIT Bombay. Hi Arnab, how have you been?
Hi Vivek, it's glad to see you after ages. And yeah, things have been good.
I'm very happy to be able to catch you in your lab and see all the equipment right behind you. It seems very interesting indeed.
Yeah, this is my home. This is where I hang out most of the time.
That's great to
So
hear. So Arnab, what are your memories of Hostel 3 and IIT Bombay? What were the important influences at that phase of your life?
oh actually way too many to be, we could probably spend an hour just talking about Hostel 3 and in general the experiences from IIT. But I mean, if I were to summarize it, I think one key thing is I learned a lot outside the classroom at IIT Bombay. In fact, during the 4 years, I think we all transitioned from being pretty much, teenagers trying to find out what the world was all about and trying to really reason through things and think about what we were doing. Because for many of us, I think we had just followed the grind coming into IIT, whether it is doing some exams, getting in, and after that, and IIT actually gave you the space to think about yourself. You were away from home, you were away, and I think I made a set of wonderful friends in IIT, many of whom are in touch right now. And thanks to all the new social media and WhatsApp and everything else, it's so easy to keep in touch with people. Uh, but these, I learned just so much from being with people in the hostel, and not just academics. Of course, there are many people I need to thank without whom I would have never cleared my courses. But even apart from that, going on treks, fighting in the mess, whatever it is, I think there's a lot of stuff that one learns about life just by living with people. And I think that's probably the most important takeaway for me.
That's very great to hear. What was your childhood like, Arnab? Any interesting memories or influences that you would like to share from your days at Campion School and Ruparel College in Mumbai?
Uh, well, I mean, I was basically a geek to start with. I mean, you know, in a way, I guess, right from school and Campion, if you ask my friends, if you would ask them, what is this guy likely to become, they would have said scientist, and that's what I am. And uh, my family sort of always encouraged me. My parents encouraged me to do science, and I've had very, very good role models around me all the time. So right in we had some nice teachers in school who sort of allowed they let people who were interested in going outside the book go outside the book. They didn't stop you from going doing that. I had an uncle who was at the Indian Institute of Astrophysics, and 1986 is when Halley's comet came about. And at that point, I was in fact, most of my high school, I was really into astronomy. I always wanted to become an astronomer. I always wanted to do. Then I realized that, I was an amateur astronomer. I could take a telescope, point it to a star. But most of the professional astronomers, for them, they didn't really need to know what was in the sky and where. It was a coordinate for them. And they were more interested in making sure that the physics was correct. And that was, I did attend some summer courses and all. It was way too mathematical. And I've been the guy who's tinkerer. I've been always, if something didn't work at home, the first question would be, have you been playing with this? Have you taken it apart? And many times it was me taking things apart. So I'm the guy who sort of takes things apart and plays with them. And so I needed something much more. It couldn't be just paper and pen and equations and solving things on a computer for me. It had to be more practical, and that's how I sort of moved more towards engineering. And once I got into IIT, it was of course engineering physics. I still had this astronomy passion, wasn't, but eventually I got into semiconductors and something which is sort of more practical. So yeah, that's sort of that's me. Yeah.
How early in your life did you actually make the choice of physics for a career? Did it happen in high school or even before?
So I don't know if it's physics for a career at all. I mean, right now, science, certainly science, but I'm not sure if it's physics because, on paper, all my degrees are in physics. But for example, in IIT, I was in engineering physics, and though I think it's rather physics heavy, I was one of the few people who was actually sort of more keen on the engineering side than the physics side. But unfortunately, the way things were, you applied to the Department of Physics. I got into a Department of Physics. I went for grad school, and I figured there's nothing in the physics department that I wanted to do. I was pretty much, though I had appeared for got admission for a PhD program. I actually took a master's because I wasn't even sure that I wanted to continue. But then eventually, I landed up working in a semiconductor lab, which was in the Department of Electrical Engineering. My mentor was in chemical engineering, and it's most of the equipment I use or the labs I had to go to make measurements were in material science. So I hung out with grad students in material science, and I realized that all these these divisions of physics, chemistry, biology, materials, whatever, are completely redundant in a way. I used to go to the physics department once a month to collect a paycheck, but that's about it. The physics guys didn't mind as long as they thought what I was doing was reasonably physics enough, and the other people also didn't mind. I could never change my department because I could never take the electrical engineering qualifier. I had no idea of communication theory and circuits and systems and power electronics and all that stuff. So I stayed in physics. I have a degree in physics, but what I do is science. I mean, today what I do is this big box you see behind me. What I'm doing is I'm reacting ammonia and trimethyl gallium and making gallium nitride and methane. Now you'll say this is chemistry, right? So I don't know. Do I do chemistry? Do I do physics? I have no clue. I do science. I can tell you that. I don't know if it made sense.
Yeah, it's very fascinating, Arnab. The other question is, what motivated you to return to India after your PhD and postdoc?
Uh, well, I mean, I pretty much, uh, of course, I mean, there are families here. That's always a very important constraint. But more than that, I think it's when I was working for my PhD, I was working on high power lasers. These are diode lasers, very 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 tiny lasers. The lasers that are there in a laser pointer or a laser printer, or these are very tiny diode lasers. I was working on the high power equivalent of them, which put out watts and not milliwatts. And at that point, the India was trying to get into these kind of devices and materials. Um, I had the expertise to do it. I had some experience in it, and the when I left the US, because I really didn't. I was pretty sure I would leave the US. I didn't particularly find the place that I'd like to stay there for very long. I went for a postdoc to Germany. I find Europe a much nicer environment. Even now, I have a lot of contacts with labs in Europe, and I keep going there once in a while, for a few weeks every summer or something. But I have exchange programs with students and things like this. But uh, uh, Europe is very different. The work culture, the availability of public transport, whatever it is, it's very very different. The whole culture is very different. But then again, coming back here, I thought it was a challenge to be able to set up a lab from scratch to make diode lasers in India. That's what I came back for, and I was being given a challenge which was interesting. I was being given funding which was pretty competitive at that time, and I thought it would be tough. I knew it would be tough, but it would be a challenge, and I thought let's give it a shot. And again, for me, TIFR or IIT Bombay, these are two places I really applied to because they were in Mumbai. I wanted to come back here because my family was here. So yeah, that's about it.
Arnab, which professors at IIT Bombay and also at your grad school at University of Wisconsin motivated and influenced you a lot?
Oh, um, hmm. Long list, long list. I mean, the thing is this. Again, I'm gonna probably this is going to be something which is not the regular answer. So I would say that let's take IIT Bombay, okay, and let's take University of Wisconsin where I went for grad school. I think as far as if I look at the sort of academic teaching goes, you'll always find a mix of people. Some people are good teachers, some people are not that great teachers. But again, what you find is people whom you can relate to, people who become mentors, and that mentorship doesn't always happen necessarily in class. So one of the reasons I went to Wisconsin is because of A.S. Mahajan, Anant Mahajan. If you remember Mahajan and Rangwala, the book we had for physics in the first year. So Mahajan, I went with him for hiking and rock climbing in IIT Bombay. And many of the discussions on life and what to do were during these things where we went rock climbing or hiking with Mahajan. Similarly, we went to the Himalayas, Gadwal or whatever else. Uh, and there also it was BP Singh who was supposedly teaching us photonics and lasers. But I don't remember a word of what he said but I know that we went to his house and he detailed, exactly which village to which village you can go and where you can stay and, on these hikes, whatever else. Um, I remember Malshe. Malshe taught the what was it, the humanities elective is what it was technically termed, but he used to also invite us to his house for these informal Hindustani classical sessions at night. And thereafter, of course, you listen to music, but you tended to discuss things about the world at large. We had S.H. Patil in the physics department who used to throw some challenging problems at us. We had professors in electrical engineering. I have no idea what those problems in basic electric circuits were, but I guess uh, you know they all influence you in some way or the other. I remember the microprocessors class where I think it was Revankar. We did this 8085 in those good old days, and he actually once told me that that this is a very neat way of doing stuff. That's the first time somebody actually told me that I've done something different, and which was like marked out. So I think there's always, and similarly, of course I didn't have to take too many classes in Wisconsin. Since I sort of gave the calls and I cleared it, so I didn't have to really take too many classes. But still, um, you can sometimes uh, learn the same thing from another person who teaches it with a completely different perspective. So let's take this dreaded book called Jackson Electrodynamics. Okay, I mean it was I don't know why they ever use this book. I mean, I really don't think it's a good book. I mean, probably it's good if you know your stuff, but it's not good if you don't know your stuff and you really want to learn. But then in IIT we did some problems from Jackson first few chapters itself. Nothing very on the very serious part of it. But it was I was deathly scared of it. I just somehow, let's hope Amol and Kaushal know how to figure out the solutions to it. We'll copy it from them. We'll figure out something. When I went to Wisconsin, we had the same things again, but the guy who taught it was an engineer turned physicist. He was an astronomer, and he was like, oh, the problem with Jackson, everybody's very happy for the first three chapters where it's all XYZ and rectangular coordinates. Once you get into these spherical coordinates and Bessel functions and all, hell breaks loose. But hey guys, why are you scared of all these Bessel functions? You never ever use them. If at all you use them where your r is very small or r tends to infinity. In both of these cases, this Bessel function just reduced to combinations of sines and cosines. If you're not afraid of sine and cosine, why are you afraid of Bessel function? you know that was his thing. And he used to come with a Coke can and say, today's lecture is on the world outside a can, i.e. I'm going to talk about cylindrical coordinates, or the world outside a sphere. I mean, he made it so relatable, and that made a big difference. You weren't scared of something. I mean, and the way the exams were not trying to see, where can this person fail in trying to, what level with this person can I set something that this guy will not be able to do, which seemed to be some of the questions that we were, in IIT. Maybe there was a reason for that, but at least the exams were such that, okay, you could, think about it. Let's see, there is no unique solution for this. Try and find out how would you solve such a problem. This is a real life problem. How would you do it? And I think there is some of those things were nice. I mean, this is an example, but just makes the point.
That's very interesting to hear, Arnab. Now, talking about your extracurricular activities, such as music and marathon, how did these activities start and how did they evolve with time?
Oh, these are actually very recent activities. I mean, at let's say, I mean, when you knew me, IIT Bombay, I was probably yes. I mean, I was in a wing that was, sort of we did go out a lot for hikes, etc. But I was never into any kind of athletics, never into any of the NSO games or anything at all. And basically, mm, by the time I was about 40, 41, I don't think I could run even half a kilometer. Definitely not. And I had no intention. I used to walk. I walk a lot. I walk fast, which is, um, um, something right from the days of having to catch trains in Mumbai, local trains. If you miss the 9:13 train, you will be in trouble. So you walk as briskly as you can to the station. But let me see. Sometime around, yeah, about 10 years back, I had this terrible corn in my foot, and I went and got it. Went to the doc, and they said, yeah, you can try all this, but finally you'll have to get it surgically removed, which I did. I was hobbling on crutches for a week or 2 weeks, and then it was fine. And again, after 6 months, it came back, and I was like, listen, I can't hobble on crutches for a month every year if they, and something. Then somebody suggested that you should just try and walk or run or something. The friction with your shoes will sort of abrade it away, and put your leg in hot water or something like that. So I started with one round of the colony. That's about a kilometer. And then one of my students said that, hey, you just need to make it long. You don't need to be fast. You just need to put in a lot. Why don't you just sign up for the marathon? So actually, it's one of my PhD students who got me signed up for the marathon. And well, it was a half marathon. The Mumbai, it was the first, and those were the days where you could actually sign up without needing a timing certificate. Now it's like like so many people that unless you have a qualifying certificate from the some earlier race, you can't get in. So I signed up for the half marathon, and oh god, that was terrible. 21 kilometers. I don't know how I made. I mean, I basically made it somehow, and then I did it, and at the end of it, uh, it was it was quite a different. I mean, it gives you a. I mean, if it isn't the marathon, I know that every January I will be doing this marathon, and for me, it's not. I don't have any time that I need to attain. I need to enjoy it, and I stop on this. It's the only one day in the year that you can walk across the ceiling, and walking across the ceiling and watching the sunrise from the ceiling is an amazing experience. You turn around and then you see the city of Mumbai. You have all these kids from the slums in Dharavi who come out and who are dying for a high five. You can it's fun. People offer you chicky, people offer you oranges. It's a very different marathon than anywhere. Now I was once luckily in Berlin for the Berlin Marathon, and that's a very professionally organized event, but it doesn't have the vibe of the Mumbai Marathon. And I don't care if I not 2020, 2019, I was not even supposed to run. I had the marathons in January. At the end of October, I was in hospital with dengue, and by the time I came out, I couldn't even walk very much, and the advice was not to run. But hey, I don't run, I walk. Right? It takes me 6 hours to complete it. I'm not in any hurry. I stop and take photographs whenever I like. And at the end of it, it's like I run not completely barefoot, but with the sort of minimal footwear. There are two things. You can run with these very nicely cushioned shoes that sort of isolate you from the road, or you can run barefoot. And barefoot, you sort of feel the road. You're alive to the city. You know that there's probably that shiny stuff there is likely is somebody's broken a booze bottle and it's lying on the side of the road. You got to be careful. You know that the pavement tells you that this is a place where there is don't step here, step here. I mean, it's much more you're connected to the city, and it's one day which is just amazing, and for that I'm willing to do a little effort. That's marathon. Just happens. And yeah, what is the other one? Music. Again, I mean, music is something I like. I like Hindustani classical music or even Western classical music. And at some point, a bunch of us in TIFR got bored, and we had another faculty member who's sort of he's a full-fledged musician, has all the equipment in the world in his place, and the whole studio. And my daughter sings, and she sings she sings really well. And they were planning to jam together and do something, and we said, hey, let's set up a little band and have some fun. And I am the sound engineer, so I kind of tweak the mixer and do things. Did it for a while. Now we don't do that anymore. And once in a while, when they need backing vocals, they said, "Yeah, to be aa jao." So yeah, why not? It's fun to do stuff other than just be in the lab all day. That's about it. Nothing serious.
By C-Link, you meant the Whirly C-Link, right?
Yeah, the Bandra Whirly C-Link.
Yes, yes. Moving over to your research, Arnab, for the benefit of our viewers, could you please explain your research and its main focus?
Okay. Basically, I work on semiconductors, and clearly the most common semiconductor is silicon. Silicon is what makes transistors. Silicon is what allows you to make, put a million transistors together or a billion transistors together and make these little chips. The chips go into computers, the chips go into mobile phones, the chips, silicon is what drives the electronics industry. There's only one problem with silicon: it doesn't emit light. And if you want a semiconductor that emits light, for example, the light emitting diodes that are, changing the face of lighting, you need to have different materials, and you can artificially create materials which have a crystal structure very similar to silicon, but will emit light. And simply this is done by taking elements from the periodic table and combining them. So you have carbon, silicon, germanium. That's the row that gives you, silicon and germanium were your semiconductors. Now germanium, if I take one atom this side, which is gallium, one atom the other side, which is arsenic, gallium arsenide is a semiconductor very similar to germanium in its crystal structure, but it emits light. And I can take not just gallium and arsenic, I can take nitrogen, phosphorus, all those elements on one side, and gallium, aluminum, indium, these elements, combine them, mix them, and make semiconductors. Now, this is obviously easier said than done. I mean, because, the composition of the semiconductor is very important. And every time you mix these materials, you get a different material which has a different sort of color of light that it can emit, what's called the band gap. And we can actually, today, we have the ability to synthesize these materials to make them in the lab atom by atom. I can actually, put down a layer of gallium atoms, put down a layer of arsenic atoms, put down a layer of aluminum atoms, give you any composition you want. We can pretty much make such a material. And basically that's what's happening in this box when it works, not now during a lockdown, but we grow gallium nitride, aluminum nitride, indium nitride, and their alloys. Now, obviously, just growing the material by itself is no fun. You need to make devices out of it. So my focus, of course, is mainly on the material side. Today, of course, the flash in your camera, that's a LED, which is a gallium nitride LED. All LEDs are based on gallium nitride, but people would like to use other materials. I mean, they are very bright, but still there are some issues, some aspects which can be improved. There's always a quest for new materials with different properties, with magnetic properties, with other thing. And at a basic research institute like where I am, what we're trying to do is trying to understand the nature of these materials. They're different semiconductors. So I pretty much play around with elements in the periodic table and try and make, these days, there are a lot of weirder semiconductors, materials like, tungsten disulfide or rhenium disulfide or rhenium selenide. And we've been trying to get our hands dirty with trying to see how we can make them as well and look at their properties. The other thing which you can do is, since we have this atomic layer control, we can make things very thin. And another beautiful thing is, whenever you make materials extremely thin, thinner than about 30 nanometers or so, which is about thinner than 1/100th or 1,000th of your thickness of your hair, their properties change in dramatic ways. And we can use the effects coming from quantum mechanics to actually tweak the properties of our materials. And so, a piece of gallium arsenide, which is 1 centimeter in size or 1 millimeter in size or 100 micrometers in size or 1 micrometer in size, has the same properties. But from 1 micrometer, when you make it 10 nanometers, properties change dramatically. And that's what we do. We can make them controllably in different sizes. That's another handle we have to play with the properties of materials.
Arnab, what are nanowires?
Nanowires. Well, imagine grass in a lawn, but a million times smaller. So basically, instead of depositing, so mostly when we grow our materials, we are depositing them atom by atom. So you deposit a layer of atoms, you deposit another layer of atoms, you deposit another layer of atoms. So this is, you're depositing instead of flat. Now, what you could do is, so when you're depositing things which are flat, it's very easy to make thin layers. So imagine a sandwich which has bread, a very thin layer of butter, and bread on top. So the layer of butter is effectively, it's what is called very thin in one dimension, but very large in the other two dimensions. Now, imagine I take this sandwich and I cut it up into strips. So now your layer of butter is going to be long, but it's thin in this direction because you grow it thin, and you cut it so it's thin in the other direction as well. So two directions are thin, one direction is large. That's like a wire. And in the wire, you can assume both sides are similar. So that's a nanowire where two dimensions are very small. Now, obviously, one doesn't do this bread butter analogy and then cut it up. You could do it, but it's very complex. There are much easier ways of doing it where you could actually grow things like grass. Just imagine, things growing up vertically from a substrate. You have something growing up vertically, which is, tens of nanometers in diameter. And the advantage is the way current would flow in this is very different from a rather thick wire. And if you want to make a transistor, for example, how do you make a transistor? Typically, in a transistor, you have two electrodes, current is flowing between them. There is a third electrode somewhere, which is, typically you call the source and drain, and you have a gate electrode on top, and you're trying to control the current flow by putting a voltage on the gate. Now, usually if the layer is flat, like most silicon transistors are, the gate is acting from one side, right? But if I had a wire, if I had a very thin wire, in principle, it could be like imagine, it's a wire is like a hose pipe carrying water. What do you do? If I squeeze the pipe carrying water, the amount of water going through will decrease. The current would go down of water. You can do exactly the same thing if you have a nanowire. You can put your gate electrode all around the wire. If you put your gate electrode all around the wire, you can sort of electrically squeeze that or electrostatically squeeze that and control the current through it very, very, you need a very low voltage to control it. So you can make very low power devices. And that's why people are looking at nanowires. I don't know if this made sense.
Yeah, that's interesting indeed. Arnab, what are the key unresolved issues in your areas of research?
Several. I'm going to limit myself actually to just the area of what are called compound semiconductors, not silicon, in materials like gallium nitride or in the new materials like gallium oxide, etc. So one is, what is the best material or the best design you want to make a high power device, right? If you want to have something which will block a high voltage and take a high current, so you can have high power switches are everywhere. What is the best material? How do you grow that material? How do you control the properties of a particular crystal orientation in this material? How do you, if you're making finally any device you make, you are trying to control where do electrons go, where do the holes go. That's what you do in a semiconductor. As long as you can control them using different materials, that's the game. Now, how do you control these, right? Can you come up with new sort of device geometries or device ideas that that would allow you, for example, in a gallium nitride transistor to have things going vertically transport rather than horizontally? How do you make sure that the fields are not? There are many issues in terms of new materials, sort of exploiting new device physics and new device geometries. Let's put it that way.
I understand.
Electric fields are great. Electric fields are great if you want to move electrons from one side to the other. But on the other hand, in an LED, one of the reasons the gallium nitride LED is not its best is because in a material like indium gallium nitride, which is used for making this blue LED, there are lots of electric fields. Now, electric fields will push electrons one way, but push holes the other way. And if you want electrons and holes to actually recombine and give you light, that's not good. So while field is good for materials and transistors, for LEDs, you don't want that field. So how can you avoid that field? So these are kind of the questions people ask.
Arnab, could you please talk about your research on masks for COVID-19 for the benefit of our viewers?
Oh yeah. So we are anyway stuck out here. The lab is closed. I don't have my students here or the staff that work in the lab. They're all at home, so we can't run the machine over here. But as you know, I'm a tinkerer. I mean, I like to sort of make stuff from whatever is available. And we've been helping a little bit with one critical area, which is on what are called these N95 masks. So, of course, I mean, there are some simple things. I don't know if you can see it on the screen, but if you just sort of look behind me, you'll see these blue colored liquids in bottles and lots of jerry cans lying on the floor. Um, so I have also been synthesizing or making a lot of hand sanitizer for our community here. Just take, alcohol and mix it with whatever you need to mix it with the WHO recipe and make sanitizer. That's the easy part. But what I'm really passionate about is we're working on N95 masks. So these are these masks which are used in healthcare for healthcare workers, and there's a shortage of them. And everybody everywhere in the world is trying, how do you decontaminate and reuse the mask? And the biologists and the virologists have different ways. They definitely know how to zap the bugs. So it could be UV light, it could be steam, it could be whatever. But once you have killed the germ, how do you know that the process hasn't damaged your mask, that your mask is still filtering at 95% efficiency? You need to measure the mask properties, the filtration properties. And a commercial unit to do this would cost tens of lakhs. And anyway, it's not going to be available during a lockdown. So what do? So with a colleague over here, Shankar Ghosh, we've come up with a very, very simple mask tester, which is built from whatever we could find. We've stolen some toys from home and a vacuum cleaner to suck the air through the mask, and we use these. There are lots of these air pollution monitors around the place, and an air pollution monitor is basically a particle counter. So we've converted these air pollution monitors into counters that can count particles going through the mask. So you can measure the filtration efficiency of the mask. So that's what I'm doing for helping with COVID-19. Me, the tinkerer, trying my best to have some fun.
That's really great. Talking about your science outreach activities, what motivated you to start the science outreach program, Chai and Why? Had you attended a science cafe in Europe when you did your postdoc in Germany?
Well, not exactly. I've been interested in, I actually, even in the US, one of the key takeaways from the US is that they take outreach very seriously, and they do it very professionally. And I think it's important, as scientists, we cannot blame students for not wanting to take up pure science as a career if we don't make it exciting. And especially so in Germany, I mean, the science cafe or the Café Scientifique is a very European concept. But in Germany, they also have a lot of the long night of science, for example, where all science institutions in a city get together. They are open all through the night. They team up with the local public transportation system so that there are buses running and shuttling people between them. So there are late night talks, and science outreach is taken very seriously. And when I came back here, I was obviously doing I was going to colleges and giving talks. I was doing again mainly semiconductor based things. But I realized that there is a very large disconnect between science and society, which is extremely strange. We are probably the only country where the constitution mandates that every citizen should develop what is called a scientific temper. Okay, but I was absolutely appalled at the world around us, where you had, I mean, even 10 years back, you had all kinds of Ganesha drinking milk, and people trying to go to these sadhus and whatever else and get all kinds of advice. And it's not new. I mean, even and it's just gotten, I think, worse over the years. And that's one aspect. The other aspect is, you live in a world today that is so technologically dominated. I mean, if I took my mobile phone and showed it to my grandparents or something, that generation, they would think it's magic, right? I mean, I can talk to somebody and see their face who is across the world, the way we're talking right now. I mean, and if you don't have a basic appreciation for science, then you cannot participate in anything which is a debate about, is technology good? Should I have wireless or whatever, what is it called, towers on the house next to me? Should I have genetically modified crops? All these, if you have to have a public debate, you need some public understanding of science. And people are interested. They would like to know. But whom do they ask? Where do they go? There was no forum for that. And I felt that a science cafe would work really well. I had, of course, seen a few in Europe. I had seen a few. The British Council had tried to do some over here, and through the British Council, I was lucky to get some science communication training. I've not been trained as such as a science communicator. My formal training is as a scientist, but I did go for some informal science communication training things, and I had this idea that we should have a science cafe in Mumbai, and I even had the name for it, Chai and Why, because you don't want anything of the word science. Science is that that subject in school that I have to study for an exam and then get done with it, mug some formulae and get done with it. We have unfortunately made science this. Science, the fact that science is nothing but the exploration of the world around us. And that world could be the world inside a cell in my body. It could be the world outside a star in a galaxy far away. But the fact that science is just exploring nature around us is completely lost. And we need to give people an opportunity to reconnect and find out what it is. And that was sort of the motivation for really going, whole hog into this and starting something like Chai and Why, and of course, things beyond that as well.
I see that a lot of effort has gone out into reaching out to the audience and relate to them. For example, when we look at the title, Chai and Why, 2G, 3G, 4G, Ye Kya Hai Ji? How did this very humorous and informative style of Chai and Why evolve?
So I think, see, again, this is it, right? Remember, I am trying to deal with society who thinks that science is that awful subject in school. Scientists are weirdos from some other planet in lab coats, right? And it's not for me, and nothing with science is for me. So we have to make it much more friendly, and that is, and unfortunately, the model of public outreach in India, so in at least it's changing, thankfully, but it has what has been called the information deficit model. So every institution, most of the science in India is government funded. Every big institution has a PRO's office or something, and they operate on what is called the information deficit principle. I know more than you do, hence I'll tell you what is good for you. Nuclear power is good for you, believe me. Okay. Or this is a press release saying we have done something. It's not a two-way dialogue. You need to talk to people. Talk to people in a language they understand. To talk to people in a way they would be attracted to even make the first contact. And hence it's important to be sort of creative in the way you approach the topic. And the title is very important. Now I can talk about how embryos develop and how an egg develops into an embryo or something. That's science. If I talk about the same thing but call it ande ka funda, more people will show up. Now, a few years back, words like 2G and 3G were on the front page of every newspaper, typically followed by the word scam. Okay. And you ask around, yeah, what is 2G? What is 3G? People don't know. They're happily unaware. Now, at this point, I thought it's a good idea. Let's tell people, how does your mobile phone actually talk to the tower? Now, if you think that I'm going to have on a Sunday morning a talk on the fundamentals of wireless communication, I can guarantee you nobody's going to wake up for it. So you have to repackage this and make it sort of cool. And hence the topic, a title, 2G, 3G, ye kya hai ji? And it was packed. Right. And we've done this for a lot of things. So one of my jobs is I don't do all the Chai and Why sessions. I'm the catalyst. I run I curate the thing. I get things together. Of course, if there is nobody there, I'll do something. The show must go on. And in the last 12 years, we haven't missed a session. But I normally talk to people from TIFR, find out what they do. People say, nahi, yaar, mera science kisi ko samjhega nahi. I say, no, don't worry. Let's find out what it is. And then we try and repackage this in a way which to make it cool. So, for example, people working on motor proteins, right? These are these things inside the cell that carry cargo from one end to other. Now it turns out for their size, they are like, fantastically powerful. So we said, okay, this is Chota Bheem. Now kids will relate to that. Things like this. So we just play with the topic. Try and come with a cool title.
That's completely amazing. Relating a protein to Chota Bheem. This is very interesting. Given your numerous awards and distinctions, Arnab, I noticed that you spent some time at Oxford University with the Chevening Fellowship for Science and Innovation. How did that experience go for you?
That was one heck of an experience. So yeah, 2012, I was very lucky to get this Chevening. It's called the Chevening Rolls-Royce Fellowship for Science and Innovation Leadership, and that's primarily because of my work on Chai and Y. And um, it was this is something which I really sort of silently tell people. It was run by the Scythe Business School. There was a home department in Oxford, and initially I was a little apprehensive about business school. What will I do in business school? But it turned out to be a good experience. I mean, the way they look at things, the way they helped me think about how to scale up Chai and Y. But I think the most important part was uh, I was a student. So I went to the UK. I went on a student visa, and I was a student at Oxford for the summer, and it was crazy. I had homework every day. I used to still try to run my lab back home over Skype, and I used to, my students used to be writing papers and all, and I had to tell them that, listen, I can't correct your paper right now because I have homework to submit tomorrow morning, and that was really it was fun. And again, Oxford is a fantastic place simply because of the breadth of people out there, the museums out there, the ability to talk to people across disciplines, across things. Right from history of science to philosophy to economics. You had just so many people uh, to talk to people to interact with, lectures to listen to. The kind of people who are coming and giving colloquia and public lectures. It was an amazing 3 months, and I think it was a great. It's also a very nice chance to sort of step out of your own life and see what's going on in the lab. So it actually I was away from family for 3 months, but it was really hard for me because I was both being in class in Oxford in the daytime in the UK, and then also trying to be waking up very early in the morning to Skype with my lab back here in Mumbai. But it was worth it. It was fun.
How did you manage these two shifts, Arnab? So you're describing that you were on two shifts during those days.
Uh, yeah, I mean, you sleep a bit in lectures, and you sort of हो जाता है. I mean, sometimes you can, for a few months, you can sort of exceed the threshold that you're working at.
Yes. Would you like to show
Weekends.
some experiments from Chai and Why?
Oh yeah, of course. Um, yeah. So I mean, I haven't. I mean, maybe I should talk about. So what is Chai and Y? I mean, Chai and Y is a fortnightly science cafe that happens in Mumbai. We have three venues. We are at Prithvi Theatre on the first Sunday. We are at Ruparel College on the third Sunday, and we're at South Mumbai at Alexandra School on the if a month has a fifth Sunday. And the aim is it's a short talk and long discussion, and it's open to everybody. There's no age limits, no nothing. Anybody who's interested, let's discuss some science over a cup of chai. Very very informal. Now, while doing this, uh, I quickly figured out that of course, I mean, we started off being intending to be a sort of platform for having discussions with adults. And of course, what we said is that the sessions which we do in summertime, those sessions that coincide with the summer holidays in Mumbai, we will make sure that even kids understand it. But eventually, first, of course, where do we don't have the concept of childcare in India. So on a Sunday morning, what do you do with your kids? You bring them along anyway. So bring them along, please bring them along. And then we found that the kids were actually asking the more, they had no inhibition. They're asking questions. They were asking the really good questions. And eventually now it's the kids who drag their parents along. And we also felt that one of the biggest things missing, even in good schools where they can teach science, is not enough experiments are being done. Kids don't do experiments. Kids don't play around doing experiments. And we decided to have these hands-on sessions for kids. And believe me, not just the small kids, the parents also, the big kids also, they've never done it when they were small. They also want to do the experiments. So we have a lot of sessions. So nowadays, as far as possible, we try and do these sessions with hands-on experiments. And um, uh, what we did is I did science in the kitchen, science in the bathroom, science in the playground, science on the beach, things like this. And then we all put things together to make some little packages called the wonderful lab called Home, experiments you could do at home. And we tried doing this in schools in Mumbai. No interest. Who wants to have extra science things? No interest. But one of my colleagues translated this into Marathi. And the response we get in rural schools is fantastic. So we have these Ghar Nawache Prayogshala experiments you can do at home. 2011 was the year of International Year of Chemistry. We did a lot of fun chemistry demos. This became Rasayan Shastra Til Gamti Jamti, which is fun with chemistry. We have a Thanda Matlab liquid nitrogen, that kind of a show. So we've done a lot of experiments which are designed for large audiences, low cost settings, low resources. You can go and do them anywhere. And the kind of experiments I like is when you can go home and do it. And so we've been now reaching about 15-20,000 kids every year with these experiments, which are the byproduct of chai and wine. I think that's probably more useful. Yeah, I can show you some experiments. Let me see. Let me just pick up something from Science in the Kitchen, perhaps. And let's see. I mean, this is a lab. We'll have to set up some things over here. So basically, what I'm going to do is I'm going to show you something about bottles, right? So we buy grains. We buy grains, rice, dal, whatever it is, rava, chana, whatever, all grains, mustard seeds. And grains are a really weird class of materials. Right? There's a thing called granular matter in physics. It behaves very weirdly. And a very simple thing is, you buy your grains in packets, typically rice, and you come home, you cut it, you pour it into a bottle, and you typically store it in plastic bottles like this, right? This is the rice. Okay, so now I have a bottle of rice. It's full. I have a bottle of rice that's empty. And you know what I'm going to do? I'm just going to take this bottle and sort of roll it down a slope to see how this bottle rolls. So let me build a little slope over here. Let's see. Vivek, can you see a little stool over here?
Yes, I can.
So all I have done is, this is a stool, right?
Yes.
I just kept something. I've kept a little book below the stool so that it's tilted. Okay, the stool is tilted. And what I'm going to do is I'm going to take my bottles over here, and as you can see, if I have an empty bottle down a slope, an empty bottle rolls down a slope. Nothing surprising in that. An empty bottle rolls down a slope.
Yes.
If I take a full bottle, this is a bottle full of rice.
Yes.
A full bottle also rolls down the slope.
Yes.
Okay. And of course, if I was doing the show, I would ask people, which one will roll faster? Do you think the empty bottle will roll faster or the full bottle? Okay. And then we'll have a race. We'll put them together and we'll take a long slope and we'll have a race. And people will try and say this or that. And then, depending on the crowd, if they're college students, I can say, hey, or high school students, I can say, hey, have you heard of moment of inertia? And we can talk about moment of inertia of a solid thing versus a hollow thing and all that stuff. But that's not the cool thing. The cool thing is, what happens when you have a half-filled bottle of rice?
Yes.
Okay. Will it roll faster than this, slower than this, somewhere in the middle? And believe me, the most typical answer we get is somewhere in the middle of these two. But the fun thing is, if you take a half-filled bottle of rice and you put it here, it doesn't roll. It's stuck. And you ask people, well, why does that happen? Why is you can push it? It'll slide. It will slide, but it won't roll. And then we talk to them about things like, well, can you see that in this, there is a certain angle at which there is a certain slope, there is a certain angle at which the rice is. And if I tilt it, there is a continuous sort of avalanche happening over here as the grains keep falling, but this angle remains pretty much the same. This angle, it's and then we can talk about it, and we can tell them how the center of gravity is such that if there's actually more, the point of contact is over here, and if I draw a sort of normal to it, there's more rice at the back, so there's something trying to push it back, things like this. So you can do an experiment. So if you're watching this, you should go home and actually do the experiment.
Yes.
Put it back, guys.
I think that was very fascinating indeed. A very nice way to introduce many concepts to to school children and everyone interested in science.
Yeah. So these are the sort of experiments we do. We just do simple experiments with things available at home, and ask some questions, and hopefully people think about it. I mean, people don't want to think. That's the problem. People want the answer to be given to them. And that's something which is a big fight, to make people think.
Arnab, would you like to introduce the audience to your close friends, namely the elements of the periodic table?
Yes. Certainly. Yeah. So one of the fascinations in me since I was a kid is the periodic table. And last year was the year of the periodic table, 2019, the International Year of the Periodic Table. And so ever since I was a kid, I was always interested in. So again, I'm not going to do this division of physics and chemistry. I'm just going to call it science. I was interested in chemistry, you can call it, because elements come in chemistry, part of science. I like elements. I used to collect elements, and one of the nice things about TIFR is in our labs we just use so many different elements. And I thought for the year of the periodic table, we should collect all the elements that are used in TIFR labs, and many of them from my lab itself and other labs in my department, and build a real periodic table. I mean, you can buy these things. You can, of course, pay a few $1,000s and buy samples of all the elements. But it's actually nice to be able to collect them yourself and, actually see where they're from and get them. Now, naturally, I do not have I didn't bother with the gases. I mean, I could seal gases in tubes, but then there's no way I can convince you that this is a tube of helium and this is a tube of oxygen or argon or whatever. So I don't have the gases. I don't have the radioactive elements. I don't have the super reactive or toxic elements and all that. But I do have a good collection of elements. And I have actually, since you had told me about this, I have set up my little collection here on the table. What I have is little plastic boxes that contain samples of the pure elements. And these are all from labs in TIFR. And I've arranged them in the shape of the periodic table. And what I really nice is I find that this has been, I've taken this across the country. I can tell you fun stories of taking all these things through airport security, but that's a separate thing. But many of the things which we are sort of told to learn by heart, or just learn how properties change down the group and across the period and all this stuff, you can actually see it. I mean, let's look at this. This is sulfur. Sulfur is a yellow powder. Can you see it? Yeah,
yes.
Sulfur. And as I go down, selenium is slightly grayish. And by the time we are at tellurium is nice and shiny, right? So the fact that metallicity increases as you go down, right? Phosphorus is these little reddish lumps, not very attractive at all. By the time you go to bismuth is nice shiny crystals. I don't know if you can see them shining. So you can actually see a lot of stuff, and all of these are in plastic boxes except one. This is iodine. I had 5 milligrams of iodine in it. It's all sort of sublimed, so there's iodine vapor in this. But I know you want to see iodine. One sec. Here is iodine.
Great.
I don't know if you can see shiny crystals inside the thing. I'm turning it so that hopefully some light gets reflected of them. But these are crystals of iodine. Yes. No, but what the other thing which I thought I should say is that for example, the rare earth elements. There's out here. I hope you can see this is gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. That's only the second half. What happened to the first half? Well, people know that there are reactive elements like sodium and potassium which are stored under oil because they're reactive. But the first half of the lanthanides are also very reactive, and we have to store them also under oil or in vacuum. And I do have those elements here. So in these little glass ampules, I have sealed these elements under vacuum, and just like we have, this is for example sodium. Sodium is sealed there. We also have lanthanum. Lanthanum is reactive, very very reactive. These elements will burn in air. Lanthanum, cerium, neodymium, which they use for magnets. These very high power magnets made from neodymium. So there are all these elements which are actually air sensitive. People don't realize that it's, people will tell you only about sodium and potassium. And also, I mean, I don't know if you've, for example, calcium. Calcium, you take it, you put it outside, it immediately oxidizes and become white. But calcium actually is a nice shiny metal. The problem is, by the time you can take it outside, put it in a tube. These are quartz tubes. You have to take it to the with an oxy hydrogen, or sorry, an oxy, well, it's actually just LPG gas. You need a gas torch to melt the tube and, evacuate it and seal it and all. It turns a little grayish by the time, but that's calcium metal. There's another, okay, I can show you another fun thing. In college, school, whatever, they tell you that some elements are magnetic. So, I think, so here's a magnet in my hand. And
Could you
they've
hold
said
it
that,
a little higher, please? Yeah.
yeah,
Yeah, we can see it now. Yes.
okay, that's the magnet. And
Yes.
here is, can you see iron, cobalt, and nickel?
Yes.
So iron is magnetic. There you see the thing
Yes.
jumping up. Okay.
Yes.
Oh, get off now.
Yes.
Okay. Cobalt is magnetic. There you go. Click.
Yes.
Cobalt is magnetic. And
Yes.
nickel is magnetic. Nickel is also
Yes.
magnetic. So these are the only
Yes.
ones which are magnetic. So
Yes.
all the other elements are not attracted to a magnet. Okay.
Yes.
But there is one more. There is one
Yes.
more that most people never talk about. And
Yes.
that's at room temperature. It's probably not very difficult in India because our room temperature is high. But in an air-conditioned lab like this,
Yes.
gadolinium over here is magnetic. So I can show you
Yes.
that. There it is. It's not a very strong
Yes.
magnet, but there it is. It got attracted. There
Yes.
it is. I could pick it up. I can pick it up. There it is.
Yes.
So very pure gadolinium is magnetic below 25 degrees centigrade or so. So 25 Celsius, that's about the limit. If it gets warm, then gadolinium is not magnetic. But
Yes.
these are magnetic things. The only other two things you might wonder about are these two powders. It's
Yes.
very difficult to get uranium and thorium and things like this. So I wrote to the International Atomic Energy Agency and I got samples of their standards for thorium ore and uranium ore. So these are not the metals, but these are the ores. But that's
Okay.
sort of the nearest I could get the things. We do have uranium as well we do use uranium metal at sometimes as a not the radioactive form, the non-radioactive form.
Yes.
But that is also a very reactive element, has to be sealed under vacuum. And here,
Yes.
this is a turning of uranium, of depleted uranium. Again, it's in vacuum because otherwise it would oxidize in air. So you know, there are a whole set of elements that are there, and yeah, the elements around us, they make up the world, and it's always fun to be collecting them. It's one of my passions to collect elements, and I have about right now 67 or some of them. Okay, let me put this back.
That was completely amazing, Arnab. Both these demonstrations were really very interesting from a very broader perspective.
Okay, there we are. Okay, back
And
here.
yes,
Yeah.
the other question was, what have been the interesting learnings from science outreach programs such as Try and Why? And from your perspective, how should science education and science communication be improved, say in schools and colleges?
Oh, I mean, at the outset, maybe I should sort of give a little disclaimer saying that um, I have no formal training in science education. Okay, I get people excited about science. My feeling is if people are excited about something, they will automatically want to learn more about it and get themselves educated. If that's the word. And unfortunately, I think the problem with education today is we are trying to stuff things inside people. We are trying to stuff people with information, and that's not the way it should be, at least for science. And I think one of the real problems with science education today is that we have disconnected it from reality. Okay, and I am appalled at my daughter is right now in the 12th, but in the last few years when she was learning science in high school, um, I have been just appalled that people can talk about uh, some aspect of science and not tell you that this is how this is exactly what is happening in your home in this thing. Um, for example, or even if it is taught to you, it is taught to you in an extremely you know uh, sort of factual manner, which can get boring very easily. We have to make it more exciting and more connected with people's daily lives. Uh, so I think that is key, to be able to make sure that the examples that we give are examples that people can relate to, and make it something which is more uh, learning, which comes through doing experiments and experiencing things. And I don't think that there is an excuse for you don't really need a fancy lab to do experiments. Uh, the home is such a fantastic place. Our kitchens, our bathrooms, or whatever, you can do experiments with very simple things. We've forgotten to observe the world around us. we don't even, I mean, you ask kids, where does the sun rise? Right? Can you tell me where the sun rises? Does it rise in the same place in summer and in winter? Can they see? Are your shadows different at different points of the year? I mean, there are so many things which we just stopped observing. Um, you ask people, what is the phase of the moon right now? Uh, I mean, okay, it's very difficult to see the moon from whatever. Maybe the pollution is so bad you can, but I think you can see the moon still. Stars you can forget.
Yes.
Um, we talk about monsoons and clouds and this and that. I mean, anything. The problem is you say, oh, that is geography, that is not science, so we can't do that. We have compartmentalized our school education system, and we've really need to make it a little bit more flexible, a little bit more interesting from the point of view of the learner. There's a lot of teaching. We do a lot of teaching. We don't check about learning. you know um,
Understand.
that's one of my sort of pet peeves about all this. Do I have solutions? I'm not saying I have solutions. That the problem is, even right now, what we do, we reach out to, even if we reach out to 20,000 kids, that's like a fraction of a tiny drop in the ocean, right? But still, I think it's better to reach out to a few of them than none of them at all. So keep doing what we're doing.
Yes.
I don't know if I
I know
answered your
that.
question.
Yes, I know that children have reacted with a lot of excitement to the Chai and Wai programs. Would you like to give some examples of the level of excitement that kids displayed during various Chai and Wai programs?
Why kids? Adults as well. I
Yes.
mean, our Chai and Wai audience, uh, a Chai and Wai audience comes in two flavors. So there are a bunch of sort of what I would call diehard, the fans of Chai and Wai, who come no matter what the topic is, whether it's physics, chemistry, biology, mathematics, they'll come anyway if they are around.
Yes.
And there are the floating crowd that there are some people who come depending on the topic. There are guys who are very interested in anything related to the body or something. They will come for a biology topic. There are people interested in black holes and all kind of exotic stuff. They'll come for those kind of talks. And there are some floating people who just happen to come in by mistake, and check it out. That's okay. So yeah, let me remember. I sometime back I was talking about these mask testing thing I was doing for COVID. So it's amazing. What happened was we needed to get particle counters. These pollution monitoring devices, I figured out that there is. I was using a particle counter from our clean room, which is like a few lakhs thing, which is not a scalable thing. I figured that there are these little pollution monitoring chips that are available, and I was trying to call people to see where I could get one in Mumbai. And I googled one of these suppliers kind of stuff, and just started calling people down the list. And the first few nahi hai, band hai, whatever. The fourth guy I called, I explained that I'm a prof at TIFR. I'm trying to do this. COVID. We need to work. We're working with the hospital. This, that, and the other. And the guy says, "You're Arnab from Chai and Wine. I've attended your talk. Bolo kya chahiye? Jo bhi mere paas hai, I'm coming. I'm ready to help you."
That's amazing.
Yeah, and that's actually how we managed to make this prototype, right?
That's
I
great.
remember we had a guy many years back. Um, he sort of used to give us a lot of feedback on the talks, and used to stay back after the talk and ask questions and things like this. And one day he told us that I'm getting married. We said, congratulations, great. Hopefully, like it's the next month, something Sunday, first Sunday he's getting married. So we said, good, you're excused, but after that, I'm hoping that two of you will come to Chai and Wai. So he said, no, my marriage is in the afternoon. I'll come in the morning for Chai and Wai and then go and get married.
That's completely
So
amazing.
these are the kind of crazy stories you hear. But no, since you talked about kids, um, I mean, we have uh, kids whose parents have decided to take them out of school, homeschool them, because they have decided that they've been, you can learn things by doing things and experimenting with things. We have kids who've asked such amazing questions, that our speakers have been totally, wow, like, you know, uh, so it happens all the time. I mean, I think the problem we have in our education system is we tell kids once they come to the fifth, sixth standards, they shut up and don't ask questions, listen to whatever the teacher is saying. inherently kids will ask questions. In fact, several of the chai and why topics have come up because at home, Antara used to ask questions to whom I had no answers. Right? Why is gold precious? It turns out it's not an easy answer. Right? Why does a ruler start from 1 and the calendar start from 1, whereas something else starts from 0? Okay, these are good questions. These are not easy. Why is one side of a chapati thin? Right? I mean, these are the kind of questions you want kids to ask. You may not have answers to them, but it's interesting to get to have kids asking these questions. And this is what happens when you provide an environment where people are allowed to ask questions. The problem is that many classrooms they're not allowed to ask questions, or ridiculed for asking questions.
So hopefully all of that should change. It's really been a very fascinating conversation with you, Arnab, and I'm really impressed, by Chai and Why and your research. And it's been a great opportunity for me to have a look at your lab. This is really wonderful. Thanks a lot, Arnab.
Well, you should come here sometime, and I can give you the proper tour and show you how we do it. Because this is only where we grow the material. That's not enough. You have to go and look at it with X-rays, look at it with electron microscopes, and take it to a clean room, make devices out of it. So what you're seeing is a very small part of the whole works. But
Yes.
yeah, sure, come down sometime.
Yeah, I'm looking forward to visit TIFR and see all these places and all the equipment along with it.
It was wonderful having a chat with you.
Same here, Arnab. So thanks a lot and see you.
Yep, see you. Bye.